All right, welcome to 1.1D, Characteristics of Graphs and Functions. And we're going to be taking a look at several examples. I'm going to run through two characteristics. One is the x and y intercepts, and the other one will be increasing and decreasing intervals. So x and y intercepts are kind of a blast from the past. We looked at them in Algebra 1. So let me just review this with you. First of all, x-intercepts. When a function has an x-intercept, the graph touches the x-axis, and the x-intercepts occur when y is equal to 0. In like manner, when we have a y-intercept, a function has a y-intercept if it touches the the y-axis, and they occur when x equals 0. So here are a few examples. This one showing you that my x-intercepts, where it crosses the x-axis, those would be considered my x-intercepts, and they're at 1, 0, and 3, 0. The y-intercept is where it crosses over the y-axis, and we just have 1 point right there, so that's 0, 1. Now notice that the partners of each of these are 0. It depends on what you're looking at, will determine where that number goes. So if we were given this example, and I asked you, is this an x-intercept or y-intercept? All you need to do is look to see where that 5 is located. It's located in the y position, so that makes it a y-intercept. Here, okay, I'd kind of tricked the class, and many of them were telling me that it's an x-intercept, some were telling me it's a y-intercept. But folks, we're not partnering with 0 here, so we don't have either. So that was kind of a trick question. We laughed about that a little bit and moved on. This one, the 2 is in the x position, so that makes it an x-intercept. Okay, increasing and decreasing intervals. Let's take a look at an example here. So an interval of increase would be determined by if the graph is going up as I read the graph from left to right. So up, flat, up, down. That's why these sections in blue are considered increasing, and the sections in red are considered decreasing. And then we have a section that's not doing either. We say that's constant. Let's look at an example. So when you are given a graph and you're asked for the intervals, it would be good for you to take out a highlighter and to highlight the sections where it is going up and highlight in a different color the sections that are going down. So that got real busy, so let's take a look at a better picture of that. Going up, down, up, all the way. And when you do intervals of increase or decrease, you are going to need to know where these turning points are, and we call these max or mins right here and here. Also, as we look at this endpoint, it's heading west, and so therefore it's heading to negative numbers, and it's going down, so that's where negative infinity comes from. This one, it's heading to the right, and it's capturing all the positive values, so that's where this came from. But when we're doing the intervals, what we want to do is we want to just kind of block out these y coordinates. And this one right here we're blocking out because even though it looks like it kind of is a little bit something going on there, this is called a point of inflection, and we will not be dealing with points of inflection this year. If you'll notice, this graph is going from concave down to concave up, and that's what determines a point of inflection. But with cases of increasing and decreasing, I think it's plain to see. If you were in a roller coaster, you're going up, down, up, and that's where we get the words increase and decrease from. So as we want to write the interval of increase, we want to take all these green sections and put them in interval form. And again, you want to start with the left side branch, and that's this one. I know some of you are wondering, what should I do? Well, you're coming from the left. All of the negative x values are being captured by this graph because this graph continues to go outward, and it will eventually capture all the negative values. Where it stops being increase is at 15, right here. And so we want to skip this branch right here and then join up with this branch right here, which starts at 22 and continues to go on forever to the right. And so the answer is infinity, 22 to infinity. The interval of decrease is just this little blue section here. So if we map this to the x-axis, we're going from 15 to 22. And that's your answer. Here's an example, something I gave out in class as a note. And again, take out your highlighter and kind of go through this as you're trying to figure out your decreasing and increasing intervals. It would be good if you did those two things in two separate colors. This is what I have, and again, those endpoints, these turning points, I should say, are important, and where the graph is heading is also important. Even though this is going up, we are capturing all the negative values, so keep that in mind. We are going to eliminate the y values because they're not going to play a part in this answer. And we're always going to use parentheses for intervals of increase or decrease, because these points where they change is not going to be either increasing or decreasing. It's kind of taking a rest and altering between those two. So the interval of decreases are all these blue sections. So coming from the left, we're going to stop decreasing at -6. And this is going to upset some of you because you're thinking it's going up, but what you're looking at is the y interval. What you want to do is always look at the x, and again, these are coming from the left, so that's -infinity. We have two more sections of blue. This little section right here starts at 8 and runs until 16. And then this little section of blue here starts at 24 and then goes forever. And some of you are going to want to put -infinity because it's going down. But remember, you're capturing all of the positive x values here. So that's going to be 24 to infinity. The interval of increases are noted in the green sections. And so the first one's fairly easy. You're going to start at -6 and end at 8. Then you're going to start at 16 and end at 24. And that's how you do these. So let's take a look at a few multiple choice examples. Which is the interval of decrease in this function? Well, that's from here to here. And again, folks, you're capturing all the x values on the left. So it's going to be -infinity to -1, which is letter B. All right. And this one, you're looking for the interval of decrease, which starts here and goes here, down. But you're capturing all of the x values that are going to the right. So it's going to start at -1 and end at positive infinity. And this is where it kind of gets tough to put this in perspective and just look at the x values. All right, here's another one. Where's the interval of decrease? Well, we've got a couple. We've got a decrease right here, and we've got a decrease right here. So as I inspect these, I don't see any from 8 to 11. So that 6 to 11 we can disqualify. And what I am going to see is that's from -infinity. That's all these x values coming from this way, all the way over to -2. Is where it is decreasing. This one, which is an interval of increase, again, we really just have one interval of increase, and that's this section right here. So coming from -infinity, we're going to stop at -3. So that's going to be, or excuse me, we're going to stop at -6 because we're looking at the x value. Sorry about that. All right, and that's where we're going to conclude this video. Hopefully this was helpful. If you missed class or anything and you still don't quite understand, then you just need to make sure you get the notes and come and see me. All right, have a great day.